Good morning, dear friends. Today we will discuss some aspects of civil engineering. What is civil engineering in general? Suppose you want to define civil engineering in a sentence. Civil engineering is the process of dealing with land and building. Any process which is done on land or creating a building is called civil engineering. So the major two elements in the practice of civil engineering are land and building. The land and building together are called infrastructure. You can call them as infrastructure. So you can even classify civil engineering as the process of creating, evolving, developing, operating, and maintaining infrastructure. So, the overall definition of civil engineering is nothing but the process of dealing with the infrastructure known as land and building, creating them, developing them, operating on them, and maintaining. All these operations, all these procedures are highly involved and it takes a lot of time to understand. So we will take one by one, gradually to know the basics of civil engineering, just the basics of civil engineering. So today we will confine ourselves to the land and building. What is a land and what are buildings? So in this section, being the part 2 of our discussion, is concentrating on the land and the building. First we will take land. Lands are open. You have open lands, but they are variety in their character. Each land varies from the other. The geographical constraints, the geographical features, the topographical features, the climatic conditions, the environmental factors, the locality, or even the location are playing a very important role in the characteristics of any land. Some land will be very suitable for civil engineering practice. Some lands are very difficult for civil engineering practice. The lands which are favorable for civil engineering activities the cost as well as the process involved in the activity will be less. But once the land is involved, the character of the land is not favorable or conducive for civil engineering practice, then that land is called a tough land or a difficult land. As majority of the good lands, or the major portion of the good land available, are being utilized for the civil engineering practice. Nowadays, usually we have only difficult lands. Tough lands have become common nowadays because the natural, conducive, favorable lands are scarce in availability. The land characterizes its features by which any of the civil engineering practices can be without great effort can be done, or is there any involved civil engineering practice required for developing the land, for improving the land? That is what is called land reclamation, land development, land refinement, land strengthening, or land stabilization. So before starting the actual civil engineering practice, a civil engineer has to concentrate on the availability of the land, its nature, its category, whether it is good or tough. We don't say bad because we should not use bad lands. If a land is supposed to be tough, we should make it conducive, we should make it favorable for civil engineering practice, then only we can use that land. We shall never do any civil engineering practice on unfavorable land. Now, the technology has got to that extent that people start constructing even on water, in water, underneath the water. That's the stage. The technology and the challenge of civil engineering, they have accomplished to a great extent that the civil engineering practice not only confined itself to land and building, it has started encroaching even water. You have underwater tunnels, you have underwater you call railway lines, you have underwater transportation system. Sea Lord, for example, Sea Lord in Cochin. It's a building actually on the lake, water. But for the time being, let us not go to that much extremity of the land. Let us confine ourselves to land and building. To categorize a land, whether it is favorable or not, depends on the type of the soil where the land is situated. The soil decides the nature of the land. Basically, there are three types of soils. There are three types of soils known as sand, silt, and clay. There are three types of soils: sand, silt, and clay. In this, the most suitable soil for a good land is sand. If a land is sandy, the underneath of the land, the bottom layers of the land are sandy in nature, it is very suitable for civil engineering practices. If it is silt, silt is in between sand and clay. And these soils are categorized according to their grain sizes, the particle sizes. When the particle sizes are coarse, I don't go deep into that, just to have a bird's eye view. When the size of the soil is coarse, visible to naked eye, coarser soil, then it is sand. If it is having coarser and the other part is called the finer, when the size of the soil is reducing, the coarser soil becomes a finer soil. So coarsest soil is sand, the finest soil is clay. Silt is in between. So coarser, in between, finer. Sand is most suitable for land, for civil engineering practice. Clay is the most unsuitable for civil engineering practice. Clay is not at all good as far as civil engineering practices are concerned. It is nature's law that the clay is very good for agriculture. Clay is very good for agriculture, and sand is not at all suitable for agriculture. Sand, if you have a sandy land, no, nothing will grow there. But if you have a clay land, you will have a very good agricultural facility. Anything will grow. Finest clay, black cotton soil. You would have heard about black cotton soil. It is very good for cotton. That's why it's called black cotton soil. Clay, black cotton soil is nothing but clay. Silt, if the coarser content is small, then sandy. If the coarser content, the finer content is more, it is clayey. If a silt is more clayey in nature, the land can be developed easily. Yes, less clay. Suppose the clay content is less in silt and coarser content is more, then it will be easy for converting the land favorably. Suppose the clayey content is more, then we have to have an involved refinement process or a reclamation process or a development process of the land before starting the actual civil engineering practice. That is, land one is according to the type of the soil. You have to classify the land according to the type of the soil. The second classification of the land is according to the terrain. Land according to the terrain. If the land is plain, a level land, it will be highly suitable for civil engineering practice. A level land. Everything, if a level-headed person is there, performance of that person will be, and the effectiveness of his activity will be very high because he's a level-headed person. So here also, if a land is level, then it is a favorable land. If the land is undulated, zig and zag, just like this, then let us continue. So, if the land is undulated like this, then that land has to be developed before the actual civil engineering practice. Sometimes the land will be like this. One part of the land will be at a higher level and the other part of the land will be at a very lower level. You may have to have a line in between. You may have to have a line in between. Some land above, some land below. It is a stepped land. It is called a stepped, abrupt. There are two types of land. One is the sloping land. The sloping land, obviously you know, it is a line inclined to the horizontal plane. Here it is not known. It is just like few portions, it will be straight, then a cut, then straight. You may have to have your line in between. Then some portion has to be lifted and some portion has to be dropped. Then only you will get that, obviously. That type of land is called the land in cut and land in fill. Some part of the portion has to be filled and some portion has to be cut. And that is called land in filling and land in cutting. That's another part. Then you have a land according to its shape. If you have a perfect shape such as rectangle, circular, usually circular land is very remote, you will not have it. Triangular, because land will always have edges, it will not be circular. Rectangular, square, trapezoid, not undulated, random shaped, different corners. Those are, if you are having regular shapes, then it will be easy for developing the land. If the land is not regular, so you have regular in shape and irregular in shape. If the land is regular in shape, development will be easy. If it is irregular in shape, development and planning will be difficult. Another is proportionate land and improportionate land. If the land is proportionate, if the sizes are having a bearing, a proportion, the length and width proportion, right? The front edge, the back this is called the depth of the land. If the depth of the land in y direction is called the depth of the land. X direction is called the breadth of the land. If the breadth of the land and the depth of the land have a proportion, then it is a proportionate land. Sometimes you see some land which will be very, very thin in its width, but it will be very large in its depth. That land, it will be very difficult to develop those lands. Some land will be very wide, but the depth will be very less. That also is similar to the previous, because if you look from that side view, the land is similar to the other thing. These deeper lands and broader lands with less depth are not favorable for civil engineering practice. So you should have a proportion between the breadth and depth of the land. It is another aspect of the classification of the land, the proportion. Then according to the location of the land which is at different regions, hilly region, if the land is in a hilly region, if the land is in a plain region, if the land is in a very cold region, if the land is in a very hot and humid region, according to the climatic conditions, lands are categorized. A land which is in a very plain region with normal temperature and pressure is the best suitable land for any civil engineering practice. So let us wind up today and try to continue later. Thank you all. God bless.